shield is resulted into action from the high energy burst released from sun. Here you can see this is the live animation. So when we have an intense burst, so that burst is actually being protected or averted by this magnetic field, and that's how the earth is protected from this high energy UV rays or X-rays or charged energy particles. Okay? All thanks to this magnetic field, geomagnetism, because of which there is a survival on our Earth's surface, because this geomagnetism used to protect us from this high energy burst. Moving ahead, see, this is the magnetic field, and when we have some sort of this solar flare, so there will be a releasing of energy, and here you can see on the polar parts you might have seen this kind of aspects where there is a glowing of sky. So this glowing of sky is primarily because of this modification in the magnetic field facilitated or caused by geomagnetism, which is disrupted by solar flare or solar wind. So when we have another lights, these northern lights will be known as what? Northern lights will be known as Aurora Borealis. And when we have these northern lights, so they will be termed as what? Aurora Borealis. They are like breathtaking natural phenomena. They used to light up the sky in the northern hemisphere, and you might have seen these vibrant display of the color. So when the Earth's and Sun's atmosphere or their atmospheric discharge used to interact with each other, means the solar flare or those high energy particles, X-rays, UV rays will going to interact with the ionosphere charged particles or these electromagnetic radiation. As a result of that, there will be a glow in sky, and that glow in sky is being termed as Aurora Borealis, Aurora Australis. Aurora Borealis is basically, solar charged particles and earth magnetic field, and both used to interact. As a result of this, what will happen? Atmospheric gases, those are there will be ionization of those atmospheric gases, and as a result of that, there will be a lights, southern lights and southern lights, which we are giving a term called as Aurora Borealis, Aurora Australis. All right. So Aurora Borealis, when we have a same thing in the southern hemisphere, and if we have a same thing in southern hemisphere, because of the same reason, we used to give a name called as Aurora Australis. Okay. So in the southern hemisphere itself, or let's say in the sky of Australia, in the sky of southernmost Australia, there could be a solar charged particles because of the solar flare, because of the solar winds, and we have a Earth's magnetic field. Okay, both used to interact with each other. As a result of that, what will happen further? If it will be facilitated, there will be a ionization of atmospheric gases in atmosphere, and there will be a glowing of southern Australia's sky, that will be termed as Aurora Australis. So this is what the reason responsible for glowing of sky on the northern pole and southern pole. Alright. Now the height of troposphere, or let's say with respect to the height of other layers on our Earth's surface, atmosphere specifically, these layers are actually different. The height of troposphere is varying. It's because of the convectional current. You will get to know in atmospheric pressure. I told you we have small concepts, and all of these concepts are interlinked together. So the reason responsible for the varying height of our atmosphere is convectional current. Yes, those when the air is there on the surface, and when that surface air is warm, and when there is a vertical movement of that air, we used to give a name called as convectional cell, or let's say convectional current. Don't confuse with the mental convectional current. Okay, mental convectional current is in the interior parts of our Earth. When I say convectional current, so they are there in the atmosphere. They are from the surface what's the height of atmosphere. So when we have these, you'll get to know uh, in a while. We will have a deep dive on that as well. So when we have a convectional current, and these convectional currents, when they used to be there in our on our Earth surface, they will lead to the modification in the limit of troposphere, which we used to call generally at 10 kilometers. That could be extended beyond that. And if the height of troposphere is modifying, the height of respective, or let's say the consequent layers, will also going to be modified. All right. So at the polar parts, the height of troposphere is sometimes 6 to 8 kilometers. At the same time, the height of troposphere at the equator is 12 to 14 kilometers. So the height of troposphere used to vary, and if the height of troposphere is varying, the height of respective, or let's say the above layers, will also vary significantly. It's because of the weather activities. You will get to know about these things when you be with me with some upcoming slides, or let's say with the upcoming topics. Then you will have a more clarity about it. But as of now, just remember this, and it's because of the it's because of the convectional current, it's because of the atmospheric convectional current, because of the warm air, the height of troposphere used to modify. I'll give you clarity whenever the topics. All right. So I hope now to have a clarity with respect to the glowing of sky, that why sky used to glow, especially with respect to the North Pole and South Pole. It's because the height is less. It's because the ionosphere, the height of ionosphere is very less. Okay. With respect to the equator, with respect to the pole, the height of ionosphere is very less. At polar region, the ionosphere is found at the height of 50 kilometers. And the same with respect to the equator, the ionosphere is found beyond 100-kilometer height. So there is a variation with respect to these layers. Okay. There. All right. Now we are moving to the next topic in this atmosphere, or you can say climatology, that is solar radiation. And we are about to know that why and how Earth used to warm, and why and how Earth used to cool. I hope you remember and you know that it's because of the sun. It's because of the sun. We have what? We have short wave energy. We have what? Short wave energy. See, the sunlight which is coming on our Earth's surface, that sunlight is comprised of what? The sunlight is comprised of high energy. Comprised of what? High energy. So it is being called as what? Short wave. Called as what? Short wave radiation. It is called as insolation. Incoming solar radiation. Okay. If if we have a short wave radiation on our Earth's surface, what will happen? Our Earth's surface will going to absorb it. Alright. Our Earth's surface is going to absorb it. As a result of this, there will be a heat at the Earth's surface. As a result of that, what you can say, the temperature is increased. Surface temperature will be increased because of the absorption of this insolation, because of the absorption of short wave radiation. Earth will get warm because of this. Now, similarly, as per the law of thermodynamics, when we have two bodies, and if these two bodies are in thermally in equilibrium state, what will happen? That the other body which is here, that other body will going to exchange heat in terms of radiation. There are three ways in which the radiation exchange could take place: convection, conduction, and radiation. So this is one of the way in which sun is exchanging heat with Earth. And when we have a thermal inequilibrium, that the temperature, or let's say the heat which is absorbed by the Earth, as a result of this, what will happen? Now, as a result, what will happen? The Earth will going to re-radiate this excess amount of heat which is actually absorbed from this insolation. So Earth used to release this heat. Earth used to release this heat in terms of long wave radiation, in terms of infrared radiation, you can say. in terms of infrared radiation, in terms of long wave radiation, because the energy is very less, or let's say the energy release is very gradual. Here the energy is very fast. I mean, see the wave, they have a more energy. Here if you see the wave, they have a less energy, and when we have a less energy, so the wavelength will be greater. So here the wavelength which is actually originating or sourced from the earth's surface, releasing the excess heat received because of the insolation, would have what? Would have longer wavelength. That's why the name is given accordingly, long wave radiation. So in short, because of the short wave radiation, because of the insolation, earth surface is warm, and because of the long wave radiation, earth surface is cool. It is as per the law of thermodynamics. Sun and earth are in thermally inequilibrium state. Sun is more warm, earth is less warm. Heat flow will be from the high temperature to the low temperature bodies, correct? Now when the sun is not present during the night, what will happen? Earth is comparatively warm. When the earth is comparatively warm, it will going to release its excess heat in terms of long wave radiation. So this is how earth used to heat up. This is how earth used to cool. You might have seen in desert areas, there is a desert, and when there is a desert, we have what? Insolation. There is a direct insolation, there is an absorption. So the sand which is there in the desert, that will going to warm abruptly and warm very fast. Okay, fastly. So when there is a sunset, or let's say, okay, when there is a sunset and after some time of sunset, that sand will start to cool. And if you might have spent one night in desert, you'll get to know that even during the summer you need a blanket during the night. If you are sleeping in a open stack, it's because that desert sand is quickly warm, cool. So it will going to quickly cool in this way. It will going to quickly warm in this. Yeah, there must be a clarity, I hope, that when it comes to the insolation based on the surface nature, whether the surface is vegetated, whether there is a tree on surface, whether there is a concrete road, whether there is a exposed ground, whether there is a reflective surfaces, based on that there will be a different level of warming. If there is a vegetation, if there is a forest, so vegetation which is there, that is going to reflect the sunlight. As a result of that, what will happen? That the forest areas usually will remain cool. Why? Because there is no absorption of insolation. That's why they will remain cool. Whereas if you are in the urban areas, we have a roads, we have a asphalt roads, we have a concrete surfaces, they will going to absorb the sunlight, and as a result of that you will feel more warming comparatively. And yes, if you are in the village areas, you will see that the vegetation, the combination of vegetation and open space which is there, or let's say if there is a water body, so there will not be a that much warming which is present in the urban areas here in this example. Why? Because the absorption is also dependent on the surface nature itself. So the temperature which is increasing, or let's say the warming of our earth, is also because of the land use change. The agricultural areas which are there, we are replacing the agricultural areas with the urban clusters, and as a result of that, the area which used to reflect the sunlight, now it is absorbing the sunlight. Concrete surfaces, asphalt roads, they are absorbing the sunlight, whereas previously with respect to the agriculture, there was some sort of vegetation, so that vegetation used to reflect the sunlight. Okay, and that's how the temperature is increasing. Now this is the perspective of global warming. We are not adding global warming here, we are actually being focused, we will focus, and we have to focus, yes, we have to focus on how the earth is getting cool and how the earth is getting warm. Alright, so this is how the earth is heat up, this is how earth is cool, and any modification in this because of the human aspect, that is being called as what? Global warming. Okay, so I hope you have a clarity that sun, the energy which we used to receive on our earth's surface, it is because of the sun. Clearly, electromagnetic energy is emitted by sun, and yes, it is in the short wave. Okay, it is in the short wave, and the solar energy which we used to receive at the top of atmosphere. Remember, at the top of atmosphere. So the solar energy which we used to receive at the top of atmosphere, that is what, around 1367 watt per meter square. I mean, this much energy we used to receive at the top of atmosphere. And when the insolation is coming into the atmosphere, why there is a change, what kind of changes will be there, due to what factors there will be changes, you'll get to know in a while. And it's because of the transparency of atmosphere, it's because of the cloud, it's because of the dust, it's because of the certain gases. This amount used to vary. Now this amount of energy is with respect to the top of atmosphere, from where the atmosphere is beginning. Let's say exosphere, let's say thermosphere. So from the beginning of exosphere or thermosphere, collectively we can say this is what the solar energy is. And when the insolation is arriving on the Earth's surface, while arriving it has to pass through the atmospheric layers, and because of the various concentration of gases, because of the various dust pollutants, because of the various dust particles itself, there could be a change in terms of this solar energy on Earth's surface. You will have a detailed overview regarding this in a upcoming slide. So sun radiates what? Short wave radiation. Earth re-radiate in terms of long wave radiation. I told you in terms of why and how. You have to remember that. I told you in geography, when there is a movement of matter, when there is a motion of matter, it's because of the gradient. Sun, high temperature, low temperature. High to low, heat will. Okay. When sun is not there, Earth is there. Earth will going to change heat with respect to the space or with respect to the other bodies. So there will be long wave radiation. And if this long wave radiation will able to pass through the atmosphere, the surface of Earth will become what? Cool. And the atmosphere of Earth will also become what? Cool.